Thank you. Welcome. I appreciate everybody's attendance. I'm Bill Carter, Chief Technology Officer for the OCP Foundation. I appreciate the opportunity to speak and to visit Japan. We've had wonderful 2 days of meetings here, visiting members, and really appreciate the attendance here today and appreciate all the activity that's going on across the community here. I'm going to talk about some of the new projects that we've announced in the last 6 months, talk a little bit about some of the contributions within those projects, and give a little bit of a look ahead. I can only talk about stuff that's new in the last 6 months because we have so many things going on that there's not enough time in the day to talk about everything. So I'll give you just a brief glimpse on some of the things that are going on across this vast community that we now have worldwide. So we have I call these 4 core projects. Our server project, networking project, storage project, and then our rack and power project. A year ago, we had a project called OpenRack, and it was focused on the OpenRack specification, that original contribution from Facebook, the design that Facebook implemented into their data center and then contributed to the open source community in 2012. We realized that there were a lot of other products that were being contributed that were compatible with OpenRack, but also compatible with the EIA 310, or also known as the 19-inch rack standard. We thought it would be much better if any discussions around the rack design, power delivery, mechanical issues, interoperability, were all addressed by the same community of engineers. And so we renamed that group the Rack and Power Group. And anything that is related to the mechanics of the rack, as well as the power delivery, and eventually the manageability of that, will be handled by this group. And there's some sub-projects that are coming out of that. So I'm going to spend a few minutes on each of these. So first off, this server project. This is where all of our contributions around processor nodes come into play here. And so obviously we have a variety of OpenRack sleds. I think we now have over 6 manufacturers that are building a variety of sleds that go into OpenRack. This year we had some contributions on some GPU-based appliances. That's certainly a hot topic, and we expect to see some more open sourcing of that and better availability of open source solutions for GPUs. We've also had and continue to have some EIA 310 or 19-inch compatible rack products and servers that are contributed. Those products are vetted, reviewed and vetted by this server work group, and they vet it against the tenets of Open Compute to make sure that any product that we do adopt or accept follows those tenets of efficiency, openness, scalability, and impact to the industry. The other block there in the lower right is a picture of the OCP MES card. How many people are familiar with the OCP mezzanine specification? So the OCP mezzanine specification is a specification for a general purpose small I/O board, predominantly used for network connections. It defines the interface that goes on the connector and interface that goes onto a motherboard, as well as the mechanical, thermal, and electrical characteristics of the board that plugs into this. There are literally hundreds of thousands of mezzanine cards that are shipped today. In fact, I think if we could count them, there'd probably be close to 1 million that are shipped every year. there's dozens and dozens and dozens of products that are designed to this standard. This standard came out in, I think it was roughly 2014. Last year, a group of companies, approximately 10 companies, started working on a revision of the mezzanine card specification. Recently, they released that specification. It's now called the OCP Mezzanine 3.0 specification. And what they did is they added PCIe Gen 3 compatibility to that. They increased the size of the PCB. They actually reversed the board placement within the system to eliminate some thermal challenges that existed. It allows for devices, silicon that produces a lot more heat to go up on that board and to be adequately cooled. And they allowed for larger area for connectors. So the 2.0 version really kind of confined you to either two SFP ports or one QSFP port. Now we're able to put 2 ports on that board. So again, it kind of supports the silicon roadmap for network adapters. It's not limited to network adapters. You can use that form factor and that device for any type of I/O, but predominantly used today for network connectivity. Oops, my laptop did go to sleep. Okay. Yeah, I'll give it some power. So anyway, that was released, and again, community involvement, over 10, I think 10 companies were part of that. They spent a year. A lot of really good engineering work went into that, looking at mechanical, thermal, routing issues, signal integrity issues. It was really exciting to see, solid engineering work being shared in an open community. Another project that's very core to the foundation is our networking project. We now have dozens of contributions that span from 1 gig to 100 gig switch appliances. Recently, there's work that's going on 400 gig appliances as well. There's a new contribution for a specification for optics. This is a specification that follows the 100 gig MSA specification for multi-wavelength CMDA type of optics. And in this is a really good example of where it's important to design things that can scale. The MSA, multi-party supply agreement, is where companies get together and agree to build something to the same specification. And it's designed by committee. The problem with that is that they have to find common ground and agree on what that design is. And they came up with a design and a specification. Facebook came along and said, I don't need an optical driver that has to work over 2,000 meters. My data centers aren't sprawled out that far. I'm quite happy with an optical connection that is spec'd at 500 meters. In doing so, it actually allows a little bit looser signal integrity and optical characteristics. It allows for a little larger dB loss, and that results in a less expensive device. It results in better yields from the manufacturer of the optics. And because of the loosening of that spec, they're able to actually reduce the manufacturing cost and reduce the cost for acquisition. So about a year ago, they contributed that spec to the OCP community. We now have 2 suppliers that actually build optics to that. And there's a cost advantage in buying that. So that's just an example of the type of work that goes on. Archana talked about open open source or embedded software. We've had 4 programs. They continue to thrive. The Open Network Installation Environment is an embedded firmware that every switch today uses as the boot path. We also have a switch abstraction interface group, and they work on an API and defining APIs that allow the software stack to run, to be programmed independently of the network processor. This allows for very fast transitions and adoption of new network processors by working through that API and preventing a lot of software recoding to occur. We have the Sonic team, originally a contribution from Microsoft, and a lot of folks from Alibaba have been involved with that group for a year now, and actually just to name 2 companies, but there's a lot of companies that are involved in the development of that open source project for the data plane control software. You'll actually see press releases and other open source projects come out. There's a project that works with Sonic. There was a project recently announced, and some proof points came out with the use of the P4 programming language. It's a runtime programming language that's being used for networking, and there's some companies that are using P4 programming language along with Sonic to produce some very cool network software that runs on these open hardware platforms. And finally, the last project is the Open Network Linux project. Again, an open source project to further the Linux OS being used as a network switch controller. Originally a contribution from Big Switch, and again, a pretty robust community maintaining that. So very excited about the work that goes on in our networking group. On our storage side, we continue to have storage appliances that are contributed to this group and vetted through this group. But in the last year, what's happened is the cloud industry has realized that the hard drives and the API that was used for hard drives that we used in our desktop products, in our laptops, isn't necessarily the best API to use in a cloud environment. And they realized that there's better ways to use, to read and write to a hard drive. This was a realization by large companies like Microsoft and Facebook and Google, yet the problem was too big for any one of those companies to solve. They realized that they had to start working together to solve this as an industry and come up with fixes. They also could not work with any one drive supplier. They needed to fix this for the entire industry, and that means that you have to have Western Digital, Toshiba, and Seagate to be part of that solution. And so the 6 companies I just named got together and agreed to work through Open Compute on defining the usage of hard drives in the cloud that would then lead to changes into the drive. And it may be mechanical changes, it could be programming changes. They've identified a half a dozen or more different opportunities to improve the performance of storage, rotating media, and they're working on those. That work is being done under a joint development agreement. All 6 of those companies have agreed that the work product will be open sourced and available for everybody under a royalty-free license. So they've already signed those agreements up front. And I'll just share one of those use cases. It's called the Fast Fail API. And if you think about hard drives in the past, you've probably seen as a hard drive starts to wear out in your laptop or in your desktop machine, that it actually it appears to slow down. It's actually not slowing down at all. What's happening is that the software, or the operating system, issues a read command to the hard drive. And the hard drive typically would read a sector and return that value. Unfortunately, as the hard drive wears out, that read doesn't occur on the first read cycle. And sometimes it has to go in a routine where it reads again and again and again. And sometimes it takes 10 or 15 reads before it actually returns a value. Sometimes it doesn't return a value, and it's wasted 10 and 15 reads before it returns, before it told you, hey, I can't read from this sector, I get bad data, and it returns an error. Unfortunately, in a cloud environment, think about how those people, if you use Facebook or you use a Baidu to do a search, think about how that's actually executed back in the data center. So if you're using Facebook and you log in and you check your friends, it gives you a status on what all your friends are doing and what messages they've posted. That data is not available on one machine. It's dispersed across hundreds of machines in their data center. And in order to gather that information and present it to you on your phone, they had to do reads from hundreds and hundreds of hard drives simultaneously. If any one of those drives were to hang up, it slows that application down. Same with search engines. It literally searches across hundreds of machines and thousands of spindles. And so when one hangs, it's a problem. So in those usage models, they realized that it would be nice if you could issue a request to read a sector and know right up front if it's going to fail. And so they're changing the API so that it allows them to ask for a read from a sector. And if it fails, that first read, it tells you immediately, I failed. Okay? And it allows the application to move on. Now, if you're using a search engine and one piece of data fails, you still got 100 other data points that came across, right? It still returned hundreds of answers. It just didn't return, there was one of them that's missing. That's okay. Right? It's totally acceptable for how we use it. And so that's an example of the types of things that they're doing within this work group. And again, the most important thing to remember is that this problem was too big for any one of those companies to solve. Too big for Microsoft or Google or Facebook to solve. Too big for Seagate, Western Digital, or Toshiba to solve. But together, they're able to solve those problems. And those problems, those solutions, will be rolled out and available to the entire industry. So, very excited to see that work that's going on. We don't do that. We just provide the mechanism to bring people together. And it's pretty exciting. And again, they're working on other things beyond that. Another core project, our Rack and Power Group. A lot going on in this group. Obviously, we continue to look at the Open Rack standard, look for opportunities to improve that. I'm going to talk about some of those things. Continue to support 19-inch product. We recognize that every data center is different. A data center that you design and build and operate in Japan is a lot different than one you operate in the U.S. The climate's different. The humidity is different. The geography challenges are different. And so it results in different cooling strategies, different power delivery strategies, different layouts in your factory. And because of that, no one solution can be the same for everybody worldwide. So we have to have solutions that work for anybody, everywhere, every country, every geography, every climate. And so we're looking at solving those, and so we give people options. So we continue to have Open Rack as a very viable, energy efficient, scalable option, but we also support our 19-inch, and we have some carrier grade variants on that, as well as just standard 19-inch compatible products that are open source. We're looking at power rectifiers, we're looking at battery backup solutions, we're looking at just making improvements to the spec. And I'll talk about some of those. So this is literally slides that are going to be discussed Tuesday at the Open Rack workshop in San Jose. One of the things that group has worked on is is the opportunity to actually take the bus bar, which normally is bolted to the back of the rack, and separate it out so that it can be shipped separately, installed separately, and so they're defining a universal fit for that bus bar so that it can be purchased, supplied by various suppliers, dropped into that rack at the point of deployment, and have it bolt together. And why is that important? Well, think about the supply chain, and think about where those racks can go. If you have any experience with co-location facilities, we know that not all co-location facilities have share the same power densities. So if you're going to go into facility A, you may have a rack that's designed for, let's say, 4 kilowatts or 6 kilowatts of power. If you're going in facility B, you may have the opportunity to put in 12 or 15 or 25 kilowatts worth of equipment in there. The bus bar that you use in rack A can be different than the one that goes into rack B. So you want to order the rack, you want to have that rack delivered, and then you can make a decision where that rack is going to go, which data center. You actually get to make that decision pretty late, and you simply bolt on the bus bar when you go to do that installation. It also allows you to reconfigure these so that you can put in multiple power shelves. They've defined a way to actually, through a naming convention, allow for different bus bars to be designed to have different locations to mount a power shelf. So again, the flexibility of the standard allows for 1 to many power shelves to be bolted in. And this is just a way to standardize on the rail. So this came about from community involvement, discussions, people that had installed OpenRack into colo locations and into private data centers. Said, we have an issue with the bus bar. We'd like to make it more modular. And so, that was the feedback from the user community, the supplier community. Listened to that feedback. Rittal, one of the rack manufacturers, offered to have their mechanical engineering team work on that problem. They came back, presented that to the community. They agreed to this, and they've produced a new specification for a bus bar interface specification that becomes an option then to have this interoperable bus bar. Another example of a community working together, again, one of the problems that they identified is it'd be really nice to have the same labels on all of our equipment. And it'd be really nice to use the same nomenclature, same labeling, same colors across all that equipment, regardless of who actually supplied it. So they came up with an indicator specification to do that. And by the way, not just on indicators, but they're also looking at labels and logos, the color of cables, and there's other stuff that's going on in this work group to try to create some standards around some of these ingredients. I'll talk about the color of cable. Wouldn't it be nice if every time you walked into a data center that you knew that a yellow cable was for a 10 gig connection, and a red cable was for a 25 gig connection? There are little things like that. Really simple stuff. So regardless of what data center you're in, if you're a service technician, it all looks the same. It makes it easy to fix, easy to identify, but more importantly, it eliminates potential problems. Most of our data center downtime is human-induced. We cause the problems. So anything we do to take we out of the equation improves the reliability of our data center, our operational reliability. So these are little things that the group is working on, but it has the potential to have a big impact. As OpenRack is deployed around the world, we now see deployments into areas where there's a lot of seismic activity. I'm from California. We live on the fault. We have a lot of seismic activity in California. Japan as well. You're very familiar with the seismic activity here. This is a contribution from Nokia of a seismic kit that actually bolts on to a standard OpenRack. And if you, this is not a really good picture, but there's crossbars on the front of that rack, and there's crossbars on the back of that rack. It's a very simple design, yet elegant in that it solves seismic issues and allows this rack to be deployed into data centers, and particularly central offices and telecom data centers that require their equipment to meet the GR64 core specifications, specifically the Zone 4, the stringent part of that, the stringent requirement for seismic zones. So again, just a part of the evolution and involvement of OpenRack. We continue and have in the last 6 months continue to have companies that have come forth and said, I have a device that I'd like to open source and contribute to the foundation. I want that device to be recognized. This is just an example of one that was recently approved. Actually, it's going through the approval process. This is from General Electric, now ABB, and it's a 380 to 480 volt three-phase AC input. More importantly, it supports a 48 volt DC output. So in OpenRack, there's options for the bus bar voltage. The typical bus bar runs at 12 volts. Actually, it's 12.5 volts. But they're optionally, there's 48 volt option. Now, we don't see a lot of usage today for 48 volt, but we believe that 48 volt will actually, we'll see more and more adoption of 48 volt as rack power exceeds 25 kilowatts or exceeds 50 kilowatts. We have customers that are actually building racks today that draw 75 kilowatts of power. And in those configurations, it's actually better to run the bus bar at 48 volts. So here's an example on how this community is enabling that change and that innovation down the road. We also have work that's going on creating some interoperability on the power shelf. And this is work that's being done by, actually originally contributed and started by Schneider Electric. They proposed the notion that we should have interoperable power shelves where we actually allow different modules to plug into this. And the reason for that is that, again, at the time of deployment, we have the option to build different power densities. We may have a 4 kilowatt rack where you can use very low cost, low output rectifiers. And in the same rack, you may want to, another data center, for example, you may want to, support 25 or 30 or 50 kilowatts of power. So you'd have a much higher rated module that you'd want to plug into the front. In this particular picture, you can see how there are 6 power modules that give you the options for 3+3 resiliency, 5+1 resiliency, or you can put them all together and have one massive 6-unit system. But also, it allows you to interchange these with modules that have battery backup or have lithium batteries in them. This would provide the UPS functionality in the rack. So rather than having a separate UPS room, now we have the capability to have the UPS functionality directly in the rack. And it gives us flexibility through an interoperable PowerShell specification. I think it's been about 2 weeks now, we announced the creation of Advanced Cooling Solutions work group, and it's actually a subgroup under Rack and Power. The feedback that we have gotten in the last 6 months is that as power densities increase, as open hardware is adopted around the globe, that there is cooling challenges that aren't necessarily met with traditional air-cooled solutions. And we have to look at non-traditional solutions to cool this equipment. We know that there's three categories of, I'll call it non-traditional cooling. First would be cold plate technology. It's liquid cooling using cold plates inside the IT equipment, manifolds on the back of the rack that distribute cold water or warm water, and then return that to the chillers or the cooling towers outside the buildings. That's one technology. Another technology is immersion cooling, where you put the complete computer into a bath, an oil bath, and there's actually different variants on that. There's single-phase material and two-phase material there. It's all part of the immersion cooling process. And then finally, another type of advanced cooling is using the use of compressed air and directing that to try to highly accelerate the air across the cooling fins, and so you can get some tremendous cooling capability. All three of those we consider advanced cooling technologies. We believe that there's an opportunity to harmonize these solutions for the betterment of the industry. And so this is feedback that we've gotten from suppliers as well as users or data center operators. The data center operators have said, you know, I like immersion cooling, I like cold plate technology, but there's 15 different suppliers and they're all different. What should we do? At the same time, we have suppliers that have said, I'd like to, I build computer hardware, I build an open rack sled, but which one do I support? So we think this is an opportunity for the community to get together and make some decisions around what's the right technology used for immersion, what's the right solution for cold plate technology, and provide that feedback to the industry so that if you're making an immersion cooling solution, that you're designing to the same requirements. So the IT people that are building computer hardware, can actually build hardware that's designed to go into that immersion tank, that's designed to work with that cold plate, or designed to work with compressed air. So we have an opportunity to harmonize on that solution. We're actually looking for companies and suppliers that are interested in being a part of that group. We announced the formation of that group 2 weeks ago with approval from our board and our technical leadership, our incubation committee. We've had people that have come forth and said, I'm interested in being a part of that. We're going to have more discussions on Tuesday in San Jose. If you're interested, please let us know. Come to the website, sign up on there. Let one of us know that you're interested in leading this off. This. By the way, I think the biggest opportunities for advanced cooling is in Asia and in Japan. I think that your challenges here are right for this type of technology. This would be a great technology for this group to work on and solve and come up with recommendations, some standards, some recommendations that the rest of the world can adopt. So that's my call to action. Get involved specifically on this project. We're looking for technical leaders. We're looking for volunteers that will help that. The last thing that we're doing, I shouldn't say the last thing because I said there's a lot going on. I'm just touching on some of the new things. One of the latest things that we did is our hardware management group has come up with a strategy aligning with the Redfish API. So Redfish is, think of it as the follow-on to IPMI for out-of-band communication, for out-of-band control and telemetry of IT equipment. Redfish is the follow-on. It's a RESTful interface to your machines. And so the Rack and Power group is now looking at how they want to use Redfish for control of the power system. So that's under development. So let me talk about that hardware strategy for a minute. As an organization, and not as an organization, excuse me, as a community, the people that have to manage hardware have got together and said, we want to align with Redfish. We think that's the best thing for the cloud industry. So the DTMF organization has written a standard, written a specification for Redfish. So we don't need to write anything. But what we do need to do is prescribe, how we use Redfish. And so they've written and released specifications on which properties that need to be supported by which devices. And the idea is that if you buy a server, regardless of who you buy it from, that it has the exact same support and it's interoperable with other manufacturers' equipment. And so they've defined that in a specification. They call it the OCP profile. We have a baseline profile, we have a server profile. And then to test equipment, we're very fortunate that DTMF has actually created a validation test, or an interop validator. And so they make it very easy that you can test your product against that. So we're just going to use their product, that validation test. And finally, we'll start taking steps to recognize products that have been tested and comply with Redfish. And we'll use our marketplace to help you identify which products are compliant to that. So let me talk a little bit about this overall strategy. So what we're doing is we're establishing, it's not we, it's the community. I keep reminding myself of that. They've established which Redfish properties that they want to apply to every machine. So think about a standard way to identify the machine. If there's there's some properties that associate with identity of a machine for inventory control and so on. All machines consume power, so obviously you can get power readings for that. You can read and write, do some flash updates, things like that. That's all part of the baseline description. Every machine, regardless of the type of machine, should support these. In addition to that, there's very specific properties that Redfish uses to get information from a server. The number of processor sockets that it has, the number of cores that are supported, the power management of those cores, the features that are built into it, the amount of memory that's in the machine, right? The amount of memory channels that it has, the speeds, those types of things. Those properties are described in the server profile. So if you buy a server or an open compute server node, our expectation is that node has been tested and works and supports the baseline configuration and the server profile. Okay? There's work going on within network, storage, and I just mentioned the rack and power group to define similar profiles. And so there's opportunities to get involved in that. What's also happened is that as we have built this strategy around Redfish and the management of open source hardware, we're also seeing some subgroups pop out of that. So our HPC group has said, gosh, I'd like to do the same, but I want to focus on how we manage servers that are used in an HPC environment. And specifically, they want to collect additional information on power consumption at a much more granular level. Basically, they want to understand less than a millisecond, how much power is being consumed. Because that's how they tune their applications in these HPC environments. Similarly, there's work going on in the storage group to gather information on the health of a hard drive. And so they're working on an API that goes in to the hard drive that will report some health characteristics. This is another opportunity to make this part of this overall architecture for managing open source software. And finally, how do we use this, right? Once we get the Redfish capability built into all the hardware, what do we do with it? Well, we need to have some orchestration software. We need to have basically a DCIM solution. And we don't have that today in the open source community. So my call to action is, if you are interested in being a part of creation of this DCIM software, if your company is working on tools to manage hardware using the Redfish interface, we would love to have you help form a community to work on this and start open sourcing this. And I bring this up to this particular group, and this group only, because look at it, you have 140 people here today. It's great that you're all together, you have a chance to talk to each other, you're all trying to solve the same problems. And so you have an opportunity to go off and do something together. And I think this is a great opportunity to work on this, you know, OCP Japan type of project. So I would encourage you to think about that in the future and see if this is something you want to do. We certainly embrace that if you wanted to, you know, go off and tackle that. And by the way, if you did, we would start connecting you with other companies that may have similar interests, or other people that would. Let's see. We have a couple of other sub-projects. I'm just going to talk on one of them that's going on, the data center facilities project. So this group is focused on the facility itself. So we have a rack and power group focused on the IT equipment. We have a data center facilities group focused on the facility. It was a group that was formed, gosh, back in 2012, but it didn't do much for 5 or 6 years. What happened about 2 years ago is we started to have engineers that were involved in data center operations and engineers that were involved in co-location services or operated colos. And they said, you know, it would be great if we got together and we authored some recommendations on the best practices of designing or operating a data center, specifically a colo data center, because there's so many of those out there. And so we had a group of individuals, and I've listed the names of those folks that participated in this, in writing this specification or guideline. And they created a guideline. It's called the Co-Location Facility Guidelines for Deployment of Open Compute Project Racks. And so you keep in mind this includes OpenRack, this includes EIA compatible equipment, it includes the Microsoft Olympus contribution. It really doesn't make any difference the type of hardware goes on in there. What they're really describing is the best practices to create a data center that has the capability of being very efficient, as well as the capability to scale and take advantage of some of these features that are coming down. It sounds kind of weird, but really simple little stuff like one of the things that we know is that when you deploy a rack, it's actually better to build the rack not in your white space, but build it in a room somewhere else, or build it off campus, or have the supplier build it and ship the entire rack to you. Now, when you do that, you end up with a rack that could literally weigh a couple thousand pounds. Okay, so you have to have a dock that you can unload it onto. Okay. Having a dock that you can unload off a truck isn't always available in a data center. So little things like that is one of the recommendations. Make sure you have a dock that you can unload it. Make sure that the dock, when you do unload it, you actually have a space big enough for the rack to fit. Okay? Make sure your doorway is tall enough that you can get the full rack into it without having to tip it over and roll it in, you know, on its side. Making sure that once you roll it into your white space, that you actually have a ramp that's not too steep. I mean, think about a rack that may weigh, let's say, 3,000 pounds, okay? Think about trying to roll that up a steep ramp. You could crush someone. I mean, if the rack started down, 3,000 pounds rolling down, and I can't stop that. You know, the only thing that's going to stop it is that door, right? And hopefully I'm not between the door and the rack when it gets there. So really simple little things, but they wrote all this down. And guess what? They had 10 or 12 people that have experienced this, that have deployed at scale, that have solved these problems. And they said, this is just really good information to share. So they put it together in a paper. They spent a year working on it, put all their ideas down, and then published it. Okay? Now, the next step they did is they came along and said, you know, it'd be really nice if we identify data centers that kind of follow those guidelines. Because if you're a small company and you're trying to become a large company and you want to, and your growth is based on or limited or you have to have a data center or an IT organization that needs to grow with it, you're going to have to go out and find efficient data centers to house that business. And so it'd be nice if, as a CIO, if you can identify which data centers in your region, in your country, that meet these requirements, right? That just have implemented good practices. And so, so what they did is they actually created a scorecard, and it's a self-assessment form. And again, downloadable. You can go to the website and get that. It allows you to go through, perform a self-assessment for that data center. And if it meets the minimum criteria, we actually are putting a logo program together, and we're going to say, we're going to give you a logo. It's called the OCP Ready logo. And you're going to get to advertise that data center is ready for scale, ready for efficiency, right? And that for a consumer, for a company that's trying to find that data center, is going to be really easy. They're going to advertise, hey, I'm OCP ready. And that CIO is going to look at that and say, I think I'll go visit that data center. So again, that was work that came out in the last 6 months. Call to action. If you're a data center operator, please look at this. This logo program will roll out in the October time frame. There's a lot of work the foundation has to do with the legal department, the trademarking department. By the way, when we trademark something, we trademark it around the globe. And so we're doing that today. We started that process. Be ready for that. A couple other new projects. We created and announced at the March Summit our Open System Firmware project. Pretty exciting projects, co-led by a firmware engineer from Microsoft, as well as a firmware developer from Google. If you think about BIOS, BIOS is a tough thing to open source because it involves a lot of licensing and a lot of proprietary code. And what we're doing is looking at everything that is used to boot up a system, to initialize the silicon and actually provide a bootloader, create the drivers to allow it to then load an OS image, and looking at creating an open source image, and hopefully the goal is that open source image, that framework can support more than one processor family. So today, if you design a Intel-based solution or a Power-based solution or a ARM-based solution, that you have 3 source trees that you have to use. And they're completely different. And we'd like to get to the point that we have some common drivers, we have a common boot structure. Obviously, the silicon initialization is going to be different, but at least the framework can be pretty similar. And it'd be nice if we get to the point where we actually have one single tree, and through Metafiles we can choose how to build that image. We're very fortunate to actually be able to work with the Linux Foundation on this. They announced a similar program called Linux Boot, and it's a Linux version of a kernel that can be embedded into this firmware that allows us to take advantage of all of the drivers and all of the security features that are built into the Linux kernel. So again, we're really shifting from a very proprietary type of BIOS to more of an open source BIOS, but also leveraging, all the features that are built into Linux, as well as leveraging the fact that there's a lot of people that understand coding in Linux, and so it's much easier to find Linux developers than it is BIOS engineers. And so again, it kind of allows us to grow and expand. Another project we're working on is security. Again, coincidentally, co-managed, co-led by Microsoft Security and the Google security guys. But again, both companies trying to solve the same problem, realizing that they're better off solving it and working on these big problems together, and also inviting the participation of another dozen companies that have exactly the same problem. We want to make sure we have a root of trust so that we know how to go is our hardware from a trusted source? Is the firmware that runs on that hardware from a trusted source? As the hardware changes ownership, do we trust the change of ownership as it goes through our systems? Understand the threat landscape and where threats come into the hardware, where threats come into our data center, and how do we mitigate those threats? So, huge problem. Again, lots of people that are interested in little bits of, I'll say, little sub-projects or topics within it. What's interesting is when you put them all together, there's probably a dozen things that you have to solve here. But, luckily, we're finding people that are interested in working on each of those little pieces. So by putting everybody together in the same community, getting them to talk and share and work together, we think we're going to have some pretty exciting stuff that comes out the other end of that. And that's it. That was a quick update, not very quick, but it was an update on just the stuff that's going on in the last 6-7 months, okay? So I didn't touch on everything. Again, thank you, appreciate it. I'm going to turn it over to Steve. He's going to give us an update.